We'll now use the same sample data we worked in the previous two parts of Chapter 9.1 to build a confidence interval for claim about two proportions. Let's read the example. Connecticut and New York are contiguous states. Both require cars to have rear and front license plates. The proportion of Connecticut illegal cars with rear license plates only is 239 out of 2049. The proportion of New York illegal cars with rear license plates only is 9 out of 550. Use 0.05 significance level to build a confidence interval estimate of the difference between the two population proportions. What does the claim that Connecticut and New York have the same proportion of cars with rear license plates only suggest? So here's our claim, that Connecticut and New York have the same proportion of cars with rear license plates only. Our null hypothesis is P1 is equal to P2. Let population of Connecticut cars be P1 and the population of New York cars be P2. We're going to compare these two populations. The alternative hypothesis H1 is P1 is not equal to P2. Let's decide on the confidence level. Our confidence level will be decided when we look at the alternative hypothesis sign. The alternative hypothesis has a not equal sign, therefore we have a two-tailed test. Since it's two-tailed test, our significance level of 0.05 will be distributed in two tails, which will make the non-significant area equal to 0.95. So here's our interval, 0.95. We'll use the Graphing Calculator and the StatCrunch to perform this operation. We'll identify the number of successes in the first population. X1 is 239, N1, the total number of cars in Connecticut, our first population, is N1. The number of successes or the cars that have rear license plates only is 9. This is our X2. And the total number of the cars in this sample is N2. If you use Graphing Calculator TI-83 or 84, go to Stat, Test, to Proportion Z Interval. It's under B. Click Enter. Enter the values of X1, N1, X2, and 2 that we identify from our data, confidence level 0.95, and click Calculate. The interval limits are 0.0828 to 0.11776. What would this limit suggest? Left limit is 0.0828. I'm going to identify my 0 as here on the number line. The first limit is past 0. The second limit is also past 0. Therefore, our interval does not include 0. If the interval does not include 0, it means there is significant difference between the two proportions. Therefore, we reject the null hypothesis about proportions being equal. And the confidence interval suggests that the p-value of the first proportion, of the first population, is greater than the value of the second population. So there does appear to be significant evidence to warrant the rejection of the claim that Connecticut and New York have the same proportion of cars with rear license plates only. So the confidence interval suggests that the first population is greater than the second population. How do we know that? Well, we know that because the interval is on the right side of the 0, is greater than the 0. If it's greater than the 0, then that means that our difference between the two proportions, P1 minus P2 is positive. And we can get the positive difference only when we subtract the smaller number from the larger number. That suggests that P1 is larger than P2. If, hypothetically speaking, we got limits that are negative, for example, negative 0.328 to negative 0.059. On the number line, this interval will be on the left side of the zero because both numbers are negative. Since it's on the left side of the zero, that will suggest that our difference, P1 minus P2, and here's our interval limits, the difference is negative. Why we can get negative difference? Well, that's when we subtract the larger number from the smaller number. So let's say we subtract 2 minus 5 is equal negative 3. That's when the difference is greater. And if our interval contains the zero, that means that there is not much difference between P1 and P2. In this case, we would fail to reject null hypothesis because there, in fact, P1 and P2 would be equal or almost equal. There will be no significant difference between them. Now let's look at how to solve the same problem using StatCrunch. In the StatCrunch, you go to Stat, Proportion Stats, to Sample, with Summary. In this case, if you have data, that we would enter a set of data or two sets of data. Enter the number of successes, the number of total observations in population 1, 2049. Enter the number of successes in the second population, 9 out of 550. Then go to perform confidence interval for P1 minus P2. Choose the confidence level, 0.95 in our case. Compute. As you can see, the limits are the same, 0.028 and 0.11776 rounded. Therefore, we make the same conclusion.